Hello students and parents, it's Mr. White here. Today we're going through Chapter 6 Practice Test. This will be a full walkthrough where I go through every problem giving commentary to really help you prepare for the upcoming test, but also to go over the concepts. This is a great way to review everything we have learned thus far in this chapter. And don't forget that what we're learning now is going to be important to remember because as this class goes, as the rest of your math career goes, it just builds on itself. So if you can understand what we're doing, amazing. So definitely put the time in there to study, to work hard, to memorize the different rules and tricks we have because it will really show off by the time you get to the test, as well as the rest of our class, as well as pre-algebra, algebra, algebra 2. Man, you guys have a fun career in math ahead of you, and we're starting now with fundamentals of math. So let's get started and dive on in. Determine whether the given value is a solution for the equation with true or false as your answer. Show your work. All right, a lot of students ask, how do I show my work? Well, we have x plus 7 equals 18. We're wanting to know, is that true if x equals 11? So showing my work would look like I'm going 11 plus 7 equals 18. I like to put a question mark, and then we do the math. 11 plus 7, yeah, actually it is. So I like to put yes, but the answer we need to put in the line would be true. I don't know. I started writing what I was saying. So true. Next one here, we have y minus 5 equals negative 2 if y equals 2. Let's check that out. So let's do 2 minus 5 equals negative 2. Well, 2 is as if we're going 2 this way and then negative 5. 1, 2, 3, 4, 5. I know that that would be negative 3. Does negative 3 equal negative 2? No. So another way of saying this is negative 3 is not equal to negative 2. So that would be false. So these I know a lot of you can do in your head, but it says show your work. So this is how we show work. All right, 3 plus n equals negative 4 if n equals negative 7. Let's plug it in and try it out. So we have 3 plus negative 7 equals negative 4, question mark. We're going 3 positively, negative 7 or 7 backwards to the left. So that is true. Yes, it does equal that. Right, last one for this section, k minus 8 equals negative 1 if k equals 5. Let's plug that in. 5 minus 8 equals negative 1. 5 minus 8 would be negative 3, and negative 3 does not equal negative 1. So this would also be false. All right, that's the first part. Let's keep on going from here. Solve each equation, show your work. These are the one-step equations, addition and subtraction. The main thing to remember here is we want to look at the number all by itself, and we do the opposite, the inverse. So if this says plus 9, what do? I say minus 9. Gets rid of it on that side. Minus 9 over here would get me 15. And then our final answer is x equals 15. This is showing my work, so it doesn't take a lot of time. I know a lot of people don't want to show work because I think you just want to speed through it and it's very fun to do it in your mind, and yes, it is. I did the mental math of 15 in my mind, but if not, I could also go like that and then figure it out as well. So there's a lot of ways of doing this, but what we're wanting to see is similar to this and just really that you're understanding what we're doing. So m minus 13, if it's minus, let's add 13. That will always cancel out. If you do the inverse of the same exact number, it will cross it out, 0. I just started crossing out because I think visually for these videos and for you as a class, it's helpful to see like, don't even worry about that. We don't need to. But if we do plus 13 there, we must also do plus 13 over here, which will get me 9. So my answer is m equals 9. r plus 7 equals negative 12. It's plus 7. So let's start with doing the inverse operation, which would be minus 7. On this side, we also minus 7, so that would be negative 12 minus 7, or negative 12 plus negative 7. So we're adding the 2 and keeping the negative sign, so it would be negative 19. R equals negative 19. If any of this is still a little bit tricky of, is it negative, is it positive? I notice for some people, you can always draw your number line. And then this would be kind of a lot, but you would, put negative 12 here. Oof, not a great 12. And then we go another 7. 1, 2, 3, 4, 5, 6, 7. And then you count 12, 13, 14, 15, 16, 17, 18, 19. Negative 19. So if you need to do that, that is okay. You can draw number lines. We're looking that you understand these concepts, and then hopefully as we keep doing more and more of the negative and positive integers, you'll get more confidence. So this says -6, so let's do the opposite. Let's add 6 to both sides. That should be 24. P equals 24. All right, this one says 4 plus t equals -3. So that is in a different format than what we're used to. But as I have mentioned in class, we just know that this is a positive 4. And how do we know that? Because it doesn't say negative. So it's kind of like if there's a negative, then we're like, ooh, it's a -4. But if it's just a 4, it's assumed it's positive 4. Same thing as saying plus 4. So I could rewrite this as t plus 4 equals -3. So if that helps you, and then you're like -4 from both sides, perfect. But if you know that this is positive, we need to do the inverse, which would be -4. So -4 and -4, that gets -7. T equals -7. All right, last one on this first page, q minus 11 equals -25. We have -11, so let's do the inverse operation, which would be adding 11 to both sides. That gets us -14. Q equals -14. So just like that, we have your first page of the practice test done. If you need more help with this, you can go through your notes, you can go through your textbook. We did a lot of in-class work and review on these, but a lot of times you just need practice. So practice, practice, practice. You can always go back in the video as well too, slow it down. Or if I'm not talking fast enough, which I think I'm talking pretty fast, you can always speed it up on YouTube. Okay, second page, solve each equation, show your work. We did one step with addition, subtraction. So we need to do one steps with multiplication and division. The main thing here is that we want to isolate the variable, the x. We always want to get x or n, whatever the variable is, k, m, we want it by itself. So what do? We do the inverse operation. So same idea here. But what we need to pick up and know is that 6x is the same as 6 times x. So if we're multiplying, the inverse would be dividing. So 6x divided by 6, that gets rid of the 6's. So we have x equals 42 divided by 6, which would be 7. So x equals 7. And that's something that you're going to want to have, including, don't just put 7, put whatever the variable is, because that's what we are solving. We want to know, what does x equal? And then I'll tell you a trick, which I showed in class, a way to check our work, because maybe you're like, I don't know, is that 7? You just plug it in, you substitute it. So put 6 times 7 equals 42, question mark, just like we did at the beginning of the test. And 6 times 7, is that 42? Yeah, it is. So I know my answer is right. So that's the thing I love about math, is we can always go back through, check our work, fill it in, like for this, substitute 7 in where the x is, and if it works, then we're like, wow, I know I got that right. All right, number 12, we have -8n equals 40. Same thing there, it's a multiplication, so we undo that with division. So we're dividing 40 by -8, so n would equal -5. This one here, this is a division problem, so we undo it with multiplication. The main way we know that is because the variable is within the fraction. So k divided by 7, that's how I would read that. In comparison to this is 3/2 w. It's not w over 2, w divided by 2, it's 3/2 times w. So if the variable is in the fraction, then that's telling me it's a division problem, so we undo that with multiplication. I just put the little .7 on both sides. That signifies I'm multiplying by both. That cancels out. K equals -3 times 7. So K equals -21. Right over here, we have 5m equals -35. That's a multiplication one. So we divide by 5, divide by 5, m equals -7. This one here, the variable is in the fraction, so we need to multiply both sides by -4. That'll cancel that out. So we're left with r equals 6 times -4. R equals -24. Up next, we have another multiplication. So we need to divide by 12, -12, I should say, to both sides. And p is going to equal 7. And I know maybe some of you can't do that in your mind, but I'm going quickly just to show you the overall thing. And then if you had to, you can go 12 into 84 and then figure out, like I know 5 times 12 is 60, so it needs to be bigger than that. How about 7 would be 4, 84, okay. Oh, 6. Sorry, I meant to do 6 first. 6 would be 272, so it's bigger, so try 7, and then you'd see 7. Okay, 7. Amazing. All right, and we can cross that out because we got rid of those. Next one here, t divided by 2.5. T divided by, so if I'm saying divided by, that means we need to multiply both sides by 2.5. And it might be helpful if when you come to the problem, you actually say it in your mind, the little voice in your head, say t divided by 2.5 divided by, oh, that means I need to do the opposite, which is multiply. So we have t equals 4 times 2.5. We can put it like this. And this is, do we remember what to do if we have one decimal place? Let's see. 0, 2, 4 times 2 is 8, plus 2 is 10. Is my answer 100? No, because we have a decimal. If we go over 1, we must go over 1 as well. And an easy way to kind of test this out is, say if it was just 4 times 2. What's 4 times 2? 8. So my number should be close to 8, but then I have 4.5s to add 4, which would be 1 and 1. So 2, 8 plus 2, 10. So that's just another way that you can kind of think of it and use mental math to kind of see like, where are you at? What number am I trying to get near? And that will help. 3 over 2w. So that is multiplying. So let us go ahead and divide by 3/2. So I'm going to write it like this, but you have to remember the rule. If we're dividing by the fraction, this was from last chapter, we need to change it to multiplication. So we have 9 over 1 times 2 over 3. From there, I could do 18 over 3, but I would need to reduce that. So let's use canceling to help us get this smaller. 3 can go into both 3 and 9. 3 divided by 3 is 1. 9 divided by 3 is 3. And then 3 times 2, 6. 1 times 1, 1. W equals 6. And then we can test that by seeing, 3 over 2 times 6 over 1. Let's see, 18. Right? Oh man, 3 over 2 times 6 over 1, 1, 3. Maybe I did this wrong. Oh yeah, it equals 9. My apologies. Yeah, 18 over 2 equals 9. That's what we're looking to get here. Oh man, okay, sorry. Yes, that is correct. 3 times 3 is 9. First I did it out fully and I'm like, let's cancel it and see if that will get me the right answer. And I thought I was looking for 6, but no, I'm looking for 9 because that's what this is right here. I already plugged 6 into it to check. So Mr. White can get confused too sometimes, but don't worry. As long as you understand what we're doing, the checking way is just an additional step that I would encourage everyone to do. So a divided by 3 over 4, don't be scared because this is a fraction within a fraction. We just need to say a divided by 3 over 4. So if we're dividing, we do the inverse, which would be multiplying. So we need to multiply both sides by that. We can cross that out. So we have negative 8 over 1 times 3 over 4 equals, and let's use canceling, 4 can go into both. So negative 2 times 3 would be negative 6. So a equals negative 6. All right, last one for this page. 5 over 6y equals negative 15. I'm not saying y over 6 or 5 over y divided by y. No, 5 over 6 times y is basically what that's saying. So if we multiply, we must divide. So that will get rid of that. Divided by 5 over 6 is the same as saying negative 15 over 1. Well, it's not the same as saying, but to solve this, we must flip this into a multiplication. We do that by using the reciprocal of this, which is flipping it. So 6 over 5. And then let's use some canceling to get this a bit smaller. 5 can go into both 5 and 15. 5 divided by 5 is 1. Negative 15 divided by 5 would be negative 3. And then negative 3 times 6 equals negative 18 over 1, but it's the same thing as just saying negative 18. So y equals negative 18. And there you have it. We got through the next page. Page 3, here we go. We're now solving two-step equations. So don't worry, don't be afraid. This is the same thing we just did in the last 2 pages. It's combining them together. We do step 1 and we do step 2. That's why it's called two-step equation. How I've always said to do it is we look for the number that's by itself. We don't care about 3x right now. So go ahead, cover that up if that's helpful. And we see plus 4 equals 19. Let's do the inverse operation of plus 4 would be minus 4. Minus 4 to both sides, I should say. Then we have 3x equals 15. Some of you would be able to do divided by 3, x equals that. What I have suggested and how I've been teaching it and showing you on the board and as I walk around is let's rewrite this for step 2. So we did step 1. Now we need to do step 2, which is 3x equals 15. This is a multiplication, so we need to undo it with division. So x equals 15 divided by 3, x equals 5. This one here, we can cover up the 5n, and we see minus 7. What is the inverse operation of minus 7? Would be plus 7 to both sides. And remember, when we do the inverse operation with the same number, it cancels it out. So we don't need to do any math there. Well, we are doing math, but we can do it expedited in knowing that we can just cross it out. So we're left with 5n equals 25. So let's rewrite that for our step 2. This was step 1 we did. Step 2 right here, divide both sides by 5. So n equals 25 divided by 5, n equals 5. All right, we have p divided by 4 plus 6 equals 11. P divided by, but we do this first. Start with step 1. So cover that up. It says plus 6, so the inverse would be minus 6 from both sides. Minus 6 will get me 5. So P over 4 equals 5. Then we can go ahead and see this is a division problem. P divided by 4, so we undo it with multiplication. So 4 on both sides we need to multiply by. That will cancel that out. P equals 5 times 4. P equals 20. These are super fun. I hope you guys find it fun because it's just systematic. We just go, go, go. And we've already practiced, on these first 2 pages, step 1, step 2, we're just putting them together. This one, it is in a different format than we're used to. So you could either rewrite this 2m plus 8 or just leave it like this and know that 8 is positive because it does not say a negative 8. So if it's positive 8, we undo that with a minus 8 from both sides. Remember that. Should be 12. Then let's rewrite it for the second step. 2m equals 12. Then we need to divide both sides by 2 because that is a multiplication. And we do the inverse, which would be division. M equals 12 divided by 2, which equals 6. So m equals 6. Last one for this section is 6z minus 3 equals negative 9. Let's cover up the 6z. So we see minus 3. The inverse operation would be plus 3. So we can go ahead and do that there. Plus 3 over here be negative 6. Let's rewrite it. 6z equals negative 6. Divide both sides by 6. And then we would see z equals negative 1. All right, I think these are so much fun. I hope you do as well. But if you are struggling, just know we go in order. So we go through step 1, which is our first page of the practice test, and then step 2, which was that second page. We're just putting them together. So if you can take your time, I would really suggest the covering it up is very helpful because I see right there it's plus 6. Okay, Mr. Wright, do the opposite, minus 6. Perfect. All right, on the bottom here, solve each equation, show your work. This is distributive property. This is what we're doing. But we've learned, I think I can do it with all of these, that we have a trick we can use. And I did it on my work, which I have on another page, and I will show you how to do it this way. This one, I'll do it in both ways, okay? But the way I'm going to show you, I'll show you the traditional first, and then I'll show you the much faster way. So if we were distributing this is the same as saying 3 times x plus, keep this, plus 3 times 2. That's why we do these little arcs to remind us. So 3 times x is 3x. We drop down the same sign, plus 3 times 2, which is 6, equals 21. Now we have it in the same format as we had up here. Cover this up. We minus 6 from both sides. That will cancel that out. 21 minus 6 be 15, right? Yes. Some mental math on the fly. Write it again. 3x equals 15. Divide each side by 3. X equals 5. But let me show you the really cool way that we learned. So what we learned in this chapter, which was so fun for me because I don't remember this growing up, and I'm like, oh, that would have been so fun. If we have it set up like this, we can divide the outside number of the parentheses on both sides to get rid of it. So let's try that out. 3 divided by 3, that's going to get rid of it, just as we've done up above. 21 divided by 3 equals 7. So then I can rewrite this, x plus 2 equals 7. Then it's a one-step equation right here. So we just minus 2 from both sides. So x equals 5. And then if I want to check that, I plug 5 in right here. 5 plus 2 is 7. 3 times 7, does that equal 21? Yes, it does. So x equals 5. The next one's to help speed it up for this video, but also to show you it's such a fun trick. Let's do the new method. So divide by 2 on both sides. So we have n minus 5 equals negative 8 divided by 2, which would be negative 4. Then we just need to do the one step of adding 5 to both sides. 1. N equals 1. For this one, first, let's get the 6 where it should be. So that is something you need to remember. The way I like to look at it is, am I going to use this method? Well, does 4 divide by 10 evenly? We learned it's 2.5 times 2.5 times 4 equals 10, but let's see if we can get it into a nicer, cleaner number. We do that by covering this up, minus 6. Let's add 6 to both sides. That'll get rid of it from this one. That'll get 16. Ooh, I know 4 times 4 is 16. So let's go ahead and divide each side by 4. Divide by 4, which is 4. But don't forget, we haven't done anything with the m plus 1, and we still need to, because right now we just have m plus 1 equals 4. So let's rewrite that, m plus 1 equals 4. Then that's still not done because m, the variable, is not by itself. I need to subtract 1, which is the inverse operation of plus 1, to get 3. M equals 3. Hooray! All right, this one, it may look scary because there is a fraction. Never fear, we can do this. So if it's a half times k minus 10 times multiplied by, we can undo that with division. So let's divide that. 6 divided by 1 over 2. So now we have k minus 10 equals 6 divided by 2. But we know to do this, let's flip it, the reciprocal, 6 over 1. That's not the reciprocal. I'm just rewriting it. 6 is the same as saying 6 over 1. We need the reciprocal of this number right here. So that would be 2 over 1. Multiply across, and we get 12. So we have k minus 10 equals 12. Then we want to add 10 to both sides to get the inverse. 10 should be 22. So k equals 22. And then last but not least for this page, and then we just have 10 more problems to go, so hang in there. We have negative 3 times y plus 4 equals 9. Let's divide the outer number on both sides to really help us out. So we have y plus 4 equals 9 divided by negative 3, which would be negative 3. Right? Yes? And then we have one step here. It says plus 4, so let's do the opposite, the inverse. Minus 4 to both sides would be negative 7. Y equals negative 7. Alrighty, there we have it. We got through two-step equations and the distributive property using the new method, but you can use the older one, but this will speed it up so much. It's so much fun. Last page, here we go. Solve each inequality and graph. So main thing to remember, this is the same steps that we have been doing, except for if we're dividing or multiplying by a negative number. So that's something you need to remember. But the fun thing to know is that we don't have to worry. We don't have to be concerned because x plus 5 is less than 12. If we just pretend that that is an equal sign for the time being, which is what we've already done, we do the same steps. We minus 5 from both sides, and then we get x is less than 12. So there we have it. Sorry, let me turn this just to make sure. No, negative 5. That's why I was like, that's not right. It's 7. So 12 minus 5 is 7, class. Good, good, good. All right, So that will go right up here. X is less than 7. And then we need to graph. And I've put this nice reminder right here so you don't forget. An easy way to do it, just put the main number and then 1 on each side. And then we need to remember, is it open circle or closed circle? The best way I can to describe it is that if we're looking at these two symbols, one has more ink. I used more ink for which sign? For this sign. So if I use more ink for the sign, that means I need to use more ink for the circle. So that will be the closed one. And then this has less ink, just like an open circle has less ink. So that's a trick that I don't know if I was taught that or if I just thought of it on the fly when I was learning this and like going over it of how to teach it, but that's the best way. And I've shared that with a couple other students and they found that helpful. So if that is very helpful for you, please take it. So we know an open circle needs to go above the 7, and then it says X is less than 7. It's smaller than, and we know that if it's smaller than, we go to the left. This one right here, n minus 3 is greater than or equal to -9. Let's add 3 to both sides to isolate the variable. Plus 3 will be -6. So what this is saying is that n is greater than or equal to -6, but we still need to graph it. So let's put -6 in the middle. And then remember, we're getting, just remember, like 0 is here. So we're going -6, -5, and then 4, 3, 2, 1, 0, and then 1, 2, 3. So the negatives can be a bit tricky if you don't remember that. So we need for sure a circle above -6, but that has more ink. There's more there. If it's greater than or equal to, it will be a filled in dot. So this is saying n is greater than or equal to -6. It's greater than, it's bigger than. So we are going to the right with our arrow. All right, up next, we have some multiplication and division to do. And then a 2-step one. Ooh, that'll be fun. So 4x, 4 times x. So we need to divide by 4 to isolate the x. So we have x is greater than 20 divided by 4, which is 5. So x is greater than 5. And then let's go ahead and graph that. We'll put 5 in the middle, 6 and 4. It is greater than, not equal to, greater than or equal to. So we need an open dot. And it's greater than, it's bigger than, so we are going to the right with our arrow. And then this one right here, y divided by -3 is less than or equal to 4. Divided by, so we need to multiply both sides by -3. So that'll get rid of it there. And then I'm not going to say y is less than or equal to. I actually need to flip this around. And why? Because we are multiplying by a negative number. If we multiply or divide by a negative number, we need to flip the sign. So this, I just turn it around, becomes y is greater than or equal to 4 times -3 is -12. So up on the line here, we put y is greater than or equal to -12. And then let's put -12 on our number line. We're counting up in this direction if we're in the negatives. Counting down if we're going this way. So it has more ink, it's greater than or equal to, so we need to fill in our dot, circle there. And then y is greater than, it is bigger than, so we are also going in the direction of the right. Last one for this section, we're almost there, hang in there. -2k plus 6 is greater than 10. First step, let's get rid of the number that's by itself. So this leads it to be -2k is greater than 4. Next step from there, let's divide by -2. Do you hear I said divide by -2? That's really important. So this becomes x is not greater than the result of 4 divided by -2. We actually need to flip the sign. So x is less than -2. So the reason we did that was because we divided by a negative number. If we divide or multiply by a negative number, we need to flip the sign. Keep the same sign. So I'm not changing this from a greater than to a less than and equal to. No, I just change it from a greater than to a less than. So k is less than -2. And then we need to graph it. So for this, let's put -2, -1, and -3. It is less than. So it's an open circle. K is smaller than. It's smaller. If we get smaller, we go to the left. And you'll see that -3 is much smaller than if you had like 1 over here. It's bigger. We get smaller on the number line as we go to the left. All right, last section here. Here we go. Solve H inequality. You don't need to graph these, but we do want to show your work. So everything up here, every section, I want to see what you're doing. So I know your minds are amazing. So amazing that you can do a lot of this in your mind. But we do need to see the work of what you're doing. So to solve each one, we've already been doing this. Let's add 7 to both sides. Plus 7 should be 6. So P is, and we need to use whatever symbol is there. P is less than 6. Unless, of course, we're dividing by or multiplying by a negative number. We still use the sign, but we just flip it. Oh, we'll have an example right here. -3m is greater than or equal to 12. Let's divide each side by -3 to isolate m. So I don't want to use this sign going this direction. M is no longer greater than because we're dividing by a negative number, so I need to flip it. M is less than or equal to -4. Hooray! All right, this one right here, t divided by 5 is greater than -2. I know t divided by 5, I'm saying the word divided by, so division. How do we undo division? We undo it with multiplication. Multiply 5 by both sides. So I'm left with t is greater than -10. But maybe the tricky thing, you're like, Mr. White, that's a negative. The negative was already on this side. It doesn't matter if we have it already on this side. What happens and why it matters of when we would switch it is if this was -5 and we're moving -5 from this side over here. We're not doing that though. We're just moving 5 over by multiplying both sides by 5. So this will be our answer. T is greater than -10. Make sure you have the negatives in everything we do if it is needed. All right, two-step equations. Here we go. 2r plus 4 is less than or equal to 18. So let's start with subtracting 4 because it's the same thing as we did on the other page. Cover it up. It says plus 4. Opposite of that, -4. All right, let's -4 to this side as well. -4 will get me 14. Let's then rewrite it. 2r is less than or equal to 14. Okay, from there, divide by 2. Divide by 2. R is less than or equal to 7. Correct. And last one, how exciting, we're here, we're almost there. So -4s minus 3 is less than 9. Let's cover up that. We see -3. What is the inverse operation? Would be plus 3. So plus 3 to this side as well will get me 12. So let's rewrite it. -4s is less than 12. Now what do? I need to divide both sides by -4. It's a negative number though, which means I need to flip the sign. So s is not less than, it is greater than 12 divided by -4, which should be -3. So s is greater than -3. All right, and there you have it. We finished. So great job. I hope this was helpful. You can always let me know if you have any questions. Usually right before the test, I will ask, does anyone have questions from this practice test that you want me to go through? I think though, if you're actually watching this, you probably won't have a ton of questions because I do actually go through it all. The harder thing I found is if you're a student, and even for myself when I was a student, you're going through it by yourself and you're like, if I can just see the steps for like a few of these, like from each one, then I can understand like, oh, this is what we're doing. Yes, I remember we've done homework, we've done quizzes, we've done so much to go through and learn this material. But what does it come down to? It comes to a lot of practice. So practice tests, practice these problems. You can find additional problems in your book through the homework chapters, review your homework. Ideally, doing the corrections is a great way to get more practice in, as long as you're actually like showing your work and doing the work. That's how you're going to get good at both these concepts and just math in general. So be encouraged, have fun with it, and I know you guys are going to do great on this test.